So welcome everyone. This is 14.3 on proofs. The essential questions for today is what is a proof? How do I complete a proof? Why do we need proofs? And how do I prove two lines are parallel, which we talked about last class. So what is a proof? A proof is essentially you are trying to relay your thinking, okay, in this type of two-column proof, okay? So a statement, the left-hand side is statements, the right-hand side are reasons. So if I post the question of who is your favorite teacher? Okay. Mr. F. Right? Okay. Why is he your favorite teacher? His teaching is awesome. What else? You went to LSU. Why is he your favorite teacher? It's funny. Okay, so a sense of humor. Is calm. Okay, so all of these are the reasons why Mr. F is your favorite teacher, right? Yeah. So just like this, we have to explain why we know our statement. Okay. So in every single step that we do in these in this two-column proof is we have to explain, even like if it's obvious. Okay, we have to explain it. All right. So how do I explain it? Well, these are the definitions that we are going to know. I passed this paper out to you guys, so you guys have that half sheet of paper. Okay. If you're adding, if you're subtracting, if you're multiplying, if you're dividing, you just got to state that it's that property. Okay, that we're adding, subtracting, multiplying, or dividing. If you are substituting something, like let's say x equals 5, and you're substituting 5 in for x in the equation, that is a property. Okay. The reflexive property is basically saying that, you know, angle A is equal to angle A. All right. It's just saying that yes, it is itself. Whenever I say reflexive property, I always think of the word reflection. So when you're looking at yourself in the mirror, right? You in the mirror is the same thing as you in real life, right? You equal you. So that's the reflexive property. The symmetric property we're not going to talk about, so you can draw a line on it. Transitive property, that is saying if A equals B and B equals C, then since A and C are both equal to B, A is equal to C. Okay, whenever I think of transitive property, I think of a train, right? They're all connected together. So if they're all connected together, then we can just take out that middle train and A equals C. Okay? These three properties are the same properties, but we are talking about physical things. Remember, symmetric property we're not talking about. Okay? And the last property or postulate that we need to know, a postulate is just a rule. Okay? is the angle addition postulate, which states, hey, if you have this picture, I can say that this small angle, angle AOB, if you add that to angle BOC, it's going to equal the big one, AOC. Okay, that's all it's saying. Two smaller angles added together equal the big one, or they can equal 180 if they're all part of a line. All right? Okay? So that's the basics of what a proof is. So we're going to jump into some examples. Please don't rush through this. All right? Please do not rush through this. So we're going to take our time. We're going to cancel out that because that's already written twice. Okay? So we're given the fact that angle 1 is equal to angle 2. Measure of angle 3 is equal to measure of angle 4, right? Once I see that, class, I'm going to draw the given out on my figure. Okay, just like that. Okay, and notice when I do draw it out, I have no tick marks, just the angle representation. So they're equal to each other. And angle 3 and angle 4 has one tick mark, so they're equal to each other. Okay, so just tell the difference between that. Yeah. That they're equal to each other. Yeah. Okay. Sometimes you're gonna end up, if they have the same markings basically, then they're equal to each other. Okay. So we're given that, and we have to prove that measure of angle ABC is equal to measure of angle DEF. Just by looking at this picture, are they? Yeah, right? One tick mark, so then they're equal to each other. They're equal to each other. So if you add these guys up and add these guys up, they're going to equal the same thing, right? That makes sense? But now we have to kind of give our reasons why we know that. Okay? So how or why do we know angle 1 is equal to angle 2, measure of angle 3 is equal to measure of angle 4? How do I know this? Because it's given to us. Yeah, it's given to us, right? We're always going to start off with the given and try to reason our way through to the proof statement. Okay? So it says with number 2, measure of angle ABC is equal to 1 plus angle 3. And these need measures. Measure of angle DEF is equal to measure of angle 2 plus measure of angle 4, right? How do I know that? It's saying if you add up these smaller ones, they equal the bigger one. If you add up these smaller ones, they equal the bigger one. The angle addition property or postulate. Okay? So now can I say this, class? From here? If measure of angle ABC is equal to measure of angle 1 plus measure of angle 3, I can actually say, class, measure of angle 1 plus measure of angle 3 is equal to measure of angle 2 plus measure of angle 4. How or why can I say this? So if you look at this, right, how or why can I say that? That is just the addition property. Yeah. Because we're adding 1 from here and we're adding 1 from here, right? 1 plus 3 and then 2 plus 4, right? This, what is the difference between 3 and 4? Or how do I say this? How do I know this, guys? It's not given, it's a proof statement. We have to prove this. We're substituting because ABC class is measure of angle 1 plus measure of angle 3, correct? And that equals measure of angle 2 plus measure of angle 4, which is measure of angle DEF, right? So I substituted measure of angle ABC here and measure of angle DEF here to get this. Okay? Questions on this first proof? Okay, let's move on to our second proof. Which is right here. So we are given the fact that angle 2 is congruent to angle 3. And we have to prove that angle 1 is congruent to angle 4. In a proof class, your first step, oh, not in this one, huh? Never mind, I'll 99.9% of the time, your first step is going to be the given step, the given statement, okay? Actually, let's just write it out. I'm not going to use, okay? So if you start off with the given, and that is given, and you know your last step, whatever your last step is, I'm going to end it in 4 steps, is going to be angle 1 is congruent to angle 4, right? That's your last step. All right. So if this lesson class is like, what are you doing? Right? And you're confused, on a proof, these 3 things, your given statement, the reason of given, and your proof statement all the way on the bottom is the least that you can do. Okay? So now, if I give you this, and we have to prove that angle 1 is congruent to angle 4, try it. Try and reason your way through to see if you can figure out how angle 1 is congruent to angle 4. Okay? Go. Okay? So here, my proof, it says angle 1 is congruent to angle 2. I know that they're congruent because vertical angles are congruent. Angle 2 is congruent to angle 3 because it's given to me. Angle 3 is congruent to angle 4 because, again, the same thing, vertical angles are congruent. Now, if if angle 1 is congruent to angle 2, angle 2 is congruent to angle 3, angle 3 is congruent to angle 4, I can say angle 1 is congruent to angle 4 because of the transitive property. Okay, the train property. All right. Okay, so it's just a different way of thinking. All right, so our next one that we're going to do the next one we're going to do is this one here. Okay. And think about how you are going to prove this one. So this is the proof. Okay, example 3. So again, how do I know angle 2 is congruent to angle 3? Because it's given. Notice that your last step is that proof statement. Okay. So measure of angle 1 plus measure of angle 2 equals 180. Measure of angle 3 plus measure of angle 4 equals 180. That is the angle addition postulate. That's saying that, hey, if you add up these two angles, they're going to add up to 180 because they're a part of the whole line, right? I'm going to skip number 4. Okay. Now, what do they do from step 2 to step 3? Or step 1 to step 2 to step 3? What do they do? Measure of angle 1 plus measure of angle 2 equals measure of angle 3 plus measure of angle 4. What do they do? What do they do from step 2 to step 3? They showed how they're equal, but what property did they use? No, because then angle 1 plus angle 2 is already here. Substitution. They substituted measure of angle 1 plus measure of angle 2. They substituted 180, right, for this one. Yeah? And how do I get to the proof statement now from step 3? Huh? We subtracted. Okay? We subtracted basically from here, from step 3, we subtracted step 1. Yeah? So if you subtract angle 2 from this side, if you subtract angle 3 from this side, we know that they're equal because of our given statement. We can say angle 1 is equal to measure of angle 4. Okay? So that is the proof here. All right. My last one for today, I believe. Oh no, it's not. So we're given that CD is parallel to AB. and measure of angle 1 is congruent to measure of angle 2. Notice that my given statement, I already put it in here. Okay, so that will help me kind of decipher what I have. Now I have to prove that angle 2 is congruent to angle 3. Okay, I have to prove angle 2 is congruent to angle 3 based off of this picture. Okay, so I'll give you guys a little bit more time to try and figure that out. So here is the plan. Okay, if you are given a blank proof like this, your first step, I don't care if it makes sense, your first step or the flow is a little bit off because of it, your first step is always going to be the given. Okay? And the reason is given. Your last step, I'm not too sure what number step it will be. So I'm just going to put the step down without a number, is your proof statement. This, if you are like totally lost, right, and don't know what you're doing, this should be your proof. Okay? All right? But no one's going to be lost in this. So I'm not afraid of that. So the second step here, right, is I know that angle 1 is congruent to angle 3. Why? Because if two parallel lines are CBT, then alternate interior angles are congruent. And 1 and 3 are alternate interior angles. Okay? Notice that my if statement, if two parallel lines are cut by transversal, it's already given to me that these two lines are parallel, and AD, I can see that's my transversal, right? And then I can say this one. Because if angle 2 is congruent to angle 1 is congruent to angle 3, therefore angle 2 is congruent to angle 3 because of the transitive property. Okay? If A is equal to B and B is equal to C, then A is equal to C, the transitive property. All right? Cool. This one is fun. I promise you. Okay? And this is where we'll end. Angle 4 is congruent to angle 13. Line T is parallel to line S. And we have to prove that line H is parallel to line G. Okay? First thing, if we have to prove that these two lines are parallel, what are the 5 relationships that I need to show? 1 out of the 5. If two lines are cut by transversal and one of these angle relationships exists, then the lines are parallel, right? That's the theorem, right? Okay. So think about that and try to come up with your proof of why or how line H is parallel to line G. So we will finish this proof out next class. Okay, and that's the video for today.